UEI Test Instruments, and joining me this evening is Mark Jones.
Yep, Mark Jones with R.A. Kaplan, so we're the Indiana representative for UEI Instruments.
And we're excited to be here to talk to you a little bit today about CO dangers, combustion training, and why this is good for business and for you and for your homeowners. So with that, I want to start with a little bit of a story that we have going on here. And so for you guys that are familiar, we're here in Indianapolis. This story actually is a local story that happened out in Shelbyville, Indiana, so not too far east of us. But I just want to tell you a little bit more about this story, and then if you want to hear the complete story, you can go to WTHR.com and watch the full video. But this story is the story of Kathy. Kathy thought she had the flu for the last 10 years. She went to all sorts of doctors, she saw all sorts of specialists, she did all of the things that you should do when you think you're sick. And unfortunately, she wasn't able to get any of the results that she was looking for. Nobody could figure out what was going on with her. She just kept going to doctors and, nothing was happening. And Kathy did something. About 10 years later, she was, after she started getting ill, she decided that she wanted to redo her bathroom. And as they were going through the entire and they asked Kathy, how long have you had this water heater in your house? And she goes, about 10 years. And that set something off for them. And luckily, they decided to do a check of carbon monoxide in Kathy's house. And it actually turns out that Kathy wasn't suffering from the flu. She wasn't suffering from some imaginary disease. She was suffering from something that was very real, and that was carbon monoxide poisoning. And so if you guys aren't familiar, carbon monoxide poisoning in your system at low levels, it just continually builds up. It doesn't go away on its own. Once you figure out that's what happens, it doesn't mean that's the end of the story either, because it's years of recovery from that. But luckily, the contractors were able to figure out what Kathy was going through, and Kathy is on her road to recovery right now. But just think about that. If you were the HVAC contractor that was in Kathy's house and you had checked the furnace and maybe, there's other sources of carbon monoxide in the house and you didn't do a general sweep. Imagine if you were that contractor on year one who would have found that. You could have saved Kathy 9 years of pain that she had to go through. So I definitely recommend go check out that story. Talk to your friends, talk to your buddies, because I'm going to tell you from my experience of going out in the field, there's a lot of Kathys out there in the world that went undiagnosed. So carbon monoxide poisoning is something that I'm I want to talk a lot about, and I want to make sure that you're aware of how dangerous that is for the homeowners and for the contractors.
Yeah. And a key thing to go along with that is look at the house and all the equipment as a complete system. We don't want to just look at that one part, which we'll talk more about later on about combustion air and things of that nature. But, we really want to look at that, evaluate that whole system, not just maybe it's a motor that's out. Hey, let's look at the entire system, not just change that one part and walk right back out the door.
Absolutely. And so I just want to give you guys some statistics on this. So carbon monoxide poisoning statistics, according to the CDC, every year at least 430 people die from accidental CO poisoning. 430 people from accidental CO. And approximately 50,000 people in the U.S. visit the emergency room every year due to accidental CO poisoning. And so those are some pretty good statistics there that say, hey, maybe we should check out what's going on in the rest of the house. So with that, I want to talk a little bit about what is carbon monoxide. We want to make sure when we're talking about carbon monoxide that we're not confusing it with carbon dioxide, so CO versus CO2. Carbon monoxide is created from incomplete combustion. It's tasteless, colorless, and odorless. And that's a very dangerous combination. And under the right circumstances, it can be fatal. Whenever it's present, you need to figure out why. And I know you guys are going out there into a lot of different places, and that's why it's so important to not only protect yourself, but to protect the homeowner or the business owner that you may be checking on right there. So what we want to talk about in the carbon monoxide awareness is it measurable? Is it safe to leave that appliance or combustion system running? Have you provided the homeowner or business owner with enough information to alert them of the hazards that are present? And would you consider this area safe for the family that you like, or is it safe for a family to live or work in? And those are really important things. I've seen it while I've been out there. There's a lot of places. Mark, you go into a lot of different places as well. Some
Right.
common places that you see, CO, that you wouldn't necessarily think about. Warehouses, when you're working with forklifts, those type of things, if areas aren't properly vented. And we'll talk a little bit more about what the levels are as we go through this presentation. So I kind of want to go through some things to remember. So over on the left-hand side of that slide that you can see there, I like things that kind of make me chuckle a little bit, but they also help me remember what's important. So carbon monoxide poisoning can also very much resemble the flu, and it can also very much resemble a good night out. So, if you're starting to talk to somebody and they're saying they're having headaches, there's nausea, they collapse, or they're just completely unconscious, there's a possibility that it could be from carbon monoxide poisoning. So in small doses, it can create chronic illness, just like Kathy over there in Shelbyville. In larger doses, as we mentioned, 430 people a year die from accidental carbon monoxide poisoning. So it can be very lethal, and it can build very, very quickly. Your safety is always a concern. We want to make sure that you're safe when you walk into a building, because you may not realize that there's carbon monoxide present, because remember, it's colorless, tasteless, and odorless. And the very last thing is, if you're testing for something that is that dangerous, you want to make sure that you have your devices calibrated regularly to ensure reliability.
Not only calibrate them, have them recertified, but also we want to turn that on outside. We're talking about this as the contractor with the technician. When you're going into that home or commercial building, mechanical room, turn your analyzer on, your CO instrument outside, not by your truck when it's running, where you're going to get exhaust, in it. But to a certain extent, these devices all zero to that ambient level. So if you had 10 or 15 parts per million CO in that house and you don't turn on until you're inside, it's going to zero to that 10 or 15 parts per million. So you turn on outside, now when you walk in, you get that increase of what it is over the ambient level.
Yeah, always turn it on outside. So, and I want to talk about how small parts per million and measuring carbon monoxide is. So I want you to kind of picture the field of dreams, and I want you to picture it just littered with baseballs out there. And all it takes to start getting into the hazards of carbon monoxide is 9 parts per million is where things start running. So I want you to imagine that field of dreams just littered with all of the baseballs, and it just takes 9 of those baseballs to be painted red. That's how small carbon monoxide, how many parts per million. And under the ASHRAE standards, a residential facility should have no more than 9 parts per million continuously. A workplace is 35 parts per million over a continuous 8-hour period. And remember that continuous is important and the amount of exposure is important. As I said earlier in Kathy's story, carbon monoxide builds up into your bloodstream. It doesn't go away immediately, and that's why they have time periods before that. And anything over 35 parts per million is considered unsafe, and the area should be evacuated immediately, windows open, personal protective gear put on when you go back in to investigate where that source is. And there's a lot of sources of carbon monoxide that can come in the house, guys. Like, you really got to pay attention. And I want to talk a little bit about, because hopefully everybody that's out there today has a carbon monoxide detector, at least in their house. And that's a great thing. But I want to talk to you a little bit about what makes those carbon monoxide detectors go off. So about 60% of those carbon monoxide alarm warnings are caused by auto exhaust. So a lot of our houses, right, we have our garages, they're attached to the house. The houses are built very tightly right now. So you pull the car into the garage, you open that door, all of that CO gets pulled out of your garage and it gets pulled right into the house. And I don't know if you guys think about it, a tailpipe starts at over 12,000 parts per million, right? I said 35 parts per million is where you need to evacuate. So if you don't have that garage door open, I know I live in Indiana. It gets cold. People want to start their vehicles before if they don't have a heated garage. You guys got to make sure those doors are always up because large amounts of CO can enter that residence. They can trip the alarms. But I do also want to mention that most of those CO alarms are designed to alarm at 70 parts per million, and that has to be a sustained 70 parts per million for over an hour to 2 hours, and that's actually by the UL code 2034.
You know, with your auto exhaust, I know in Indiana they recently passed a law, hands-free now, for your cell phone. So, especially some of our more elderly, residents may come home, their phone is connected to their car, they're in the middle of a conversation, they pull inside. What do they do out of habit? You hit the button to, close the automatic door, and if they're still in that conversation and don't think to shut the car off, that's a lot of CO that's going into that space. So, just because we'll talk more about other sources, but that's where I say kind of look at that system as a whole, not just the equipment that you're there servicing.
So another source of the CO is the backdrafting appliances. I mentioned earlier that buildings are built very tight because we don't want unwanted hot air or cold air entering in the building. But these conditions, they can cause negative pressures and they can prevent CO from leaving or in the case of the garage, quickly entering the building. So anything that's backdrafting, right, it's going to have a flue that's going to go out. And if your neighborhood's like my neighborhood, I have a lot of squirrels going on in my neighborhood. And squirrels are little rats with tails that like to build nests, and they like to build nests in flues, chimneys, those type of things. And we have those things called birds that also like to do the same thing. And all it takes is one of them building a nice nest in there, and suddenly I have carbon monoxide getting poured back into my house because it can't escape. And another thing to talk about, that story of Kathy goes back to the gas water heaters. They can be a potential source. We talked about, you're in there to do the clean-in checks and the repairs and the maintenance on the furnaces, but you have to think of all the other sources. Anything that's going to be gas-fired is a potential source of carbon monoxide. So you have your hot water heater, you have your oven, you have, you could have your dryer. Yep. There's a lot of different things in a house that this could potentially happen to. So making sure all of those vents and everything are cleared is a very important thing, and making sure we don't have any gas leaks either.
And her situation is found by a remodel. In some cases, you remodel the kitchen. What they do, these fancy kitchens now, you put a big range hood in, okay? And if you take your can of great stuff, your tube of caulk and silicone, sealed up everything you can, that range hood may be enough to turn that whole house negative pressure. So, when you go to check draft on appliance, go through, turn on all the bath fans, turn on the kitchen range hood, turn on the dryer, everything that's going to compete for the air in that house, and see what's going to win. Because typically in the flue, the draft is about 2/100 of an inch of water column negative pressure. So it doesn't take much of a powered fan to overcome that small amount of draft to get spillage back into the house rather than going up the chimney.
And you might know a thing or two about that, right, Mark?
Yep.
You just went through all of that, made sure it was all good at your house?
Yep, we've actually did just finish our kitchen. We didn't change the range hood though, so
okay,
we're good.
So you're
good. Yeah, my equipment's 2 pipe, so it's bringing outside
all
air,
right.
so
Just
good.
making sure, because we don't want you to get missed. Because unfortunately, sometimes when you do things for yourself, you forget, or for others, you forget to do it for yourself. So another source that accounts for CO alarms going off in houses is cracked heat exchangers. Cracked heat exchangers, though, only consist for about less than 10% of the CO alarms going off. So I kind of want to make sure that you are aware of that. Cracked heat exchangers, we know, are a very real thing. And, everything that's man-made eventually will break down. Cracks in heat exchangers do happen. If you don't have the proper static pressure going across, you can actually burn out those heat exchangers a little bit quicker. So, you want to make sure that you're looking for the visual signals like soot and rust. And you want to make sure that, you have a combustion analyzer that's going to allow you to do a heat exchanger integrity test. It's a great practice to go into. It helps you find those things that you may not have been aware that exist right there. Sometimes those cracks just aren't as obvious as one would think. So having a proper combustion analyzer that'll test that for you is important.
Yep, so we got a question.
Yeah.
So.
We got a question from Charles. So His question is CO a real problem on a 95% furnace, or does it test the same as an 80%?
Okay, so the question is the CO a problem on a 90% as well as an 80% furnace, and do they test the same?
Do they
Is
test
what?
the same,
Yep.
like a 95 versus an 80?
Sure, and that's a really good question. You know, one of the big differences, you know, between typically a 95% furnace and an 80% furnace is an 80% furnace is what's commonly referred to as a single pipe. So, you know, we're drawing air in, you know, from around the appliance, you know, whatever room it is in, and we're venting that outside. Most 90% furnaces are installed in a two-pipe application, where now we're bringing in combustion air from outside in a pipe, and then we're venting outside in a pipe. Okay, so that does help from the aspect that if that house is sealed up tight, we're not relying on infiltration air to have enough air for combustion because we're providing a pipe outside. Now, in the case of a defective heat exchanger, if that heat exchanger fails, you can still have CO leaking into the space, into the home or building when that heat exchanger fails. And you know, if we look at that slide, one thing to keep in mind is that the inside of that heat exchanger is under a negative pressure, okay? Because we've got a combustion fan that's drawing our flue gas through the heat exchanger and up the vent. When the circulation fan is running, the outside of that heat exchanger is under positive pressure. Okay? So it's important to check our flue gas composition and not just go around to the registers and, you know, take my probe and say, hey, do I have any CO coming out of that vent? You know, if you have a crack, you're going to find a change in your combustion composition before you start to get CO out into the house because of that pressure differential.
Awesome, great. And then the next quick question follow-up on that from Jeremy. He asked, how do you do a heat exchanger integrity test?
Oh, that's a great question. How we do a heat exchanger integrity test. Yeah. Depending on the model, some of those have a test built into it, and what that test is doing is we're taking a sample of the flue gas after the burner has lit and is on for a little bit, but before our air circulation fan has started. Okay? When the fan starts, we hit the next button, which starts a timer. And it waits, and it's either 60 or 90 seconds that waits, and then takes another sample. Then what that analyzer does with that built-in test is it compares those two. And it says, okay, before my fan was on, my oxygen was X%, I had so much CO. After my fan came on, what was my oxygen, what was my CO? Okay? If my heat exchanger is doing the job that it should, because its job is to keep my flue gas and the air circulating through the home separate. So as long as that heat exchanger is doing its job, I really shouldn't see a change in my flue gas composition, right? Because those are kept separate. And it may fluctuate a little bit because combustion, you know, isn't a rock solid process. It's going to fluctuate with air pressure change and things of that nature. But if I see a substantial change in any of my readings when my fan comes on, that's a pretty good indication that I've got a problem with my heat exchanger.
Well, thank you.
So a few things to look at when we're talking about CO when you're there. When you're doing your visual inspections, if you see soot around, probably a pretty good indicator that you're having some CO leakage coming out. If you start seeing dust deposit around the door, that can indicate that your structure is under pressure. We always want to make sure that the flue pipes are in good shape. If you see any rusting, that's a good sign that CO is going to be able to leak out. And you also want to make sure that the ductwork that's old, if it has any visual openings or any of those leak points, those type of things, you can cause the house to be in negative pressure and you can cause CO to pour in. So, you know, you want to make sure you're looking for the visual, but you want to make sure that you have the right tools that you're going to be able to go through and really verify that for it. And that's going to be a running theme about verification and documentation as we go through this.
Yeah, another clue, if we look at that picture, hop back there, we see that boiler there. And not sure how old that boiler is, but that that flue pipe looks pretty new. So if we go into an old piece of equipment that's got new flue pipe on it, that may be a clue to look at. Hey, what's going on? Why did that vent pipe fail? You know, maybe we've got condensation we shouldn't have, cause it to rust out, have poor draft or what have you. So, you know, just kind of some of those visual clues when you're looking at that equipment. Maybe you're in there because the aquastat failed on that boiler. But when you see that new flue pipe, think, maybe I'll look at something else and see what else we've got that's happening with that system.
And so the reason that we're here, why test? So there's a couple of different reasons to test, right? So we want to make sure that we're managing the fuel costs. We want to make sure that the furnace or the boiler that we're working on, it's putting out the proper efficiency. And if it's not, we probably need to figure out why. We also want to manage the emissions that are going into our environment, right? CO, CO2, NOx, they all contribute to pollution. And we want to minimize the risk of CO poisoning. As we mentioned multiple times, CO can be fatal, can be very harmful, and we want to make sure you, the homeowner, the business owner, are all very, very safe. There's also going to be another component that we'll talk a little bit about that has to do with warranty, peace of mind, and those type of things, and just making sure that we look professional when we go into the job site. So we want to take just a moment, and we're going to talk a little bit about what really is combustion. I'm going to let Mark go ahead and take over this for us.
So I'm not going to get too deep into chemistry, right? I'm not going to do too much of a chemistry lesson, but
I did not think I was ever going to have to use that after high school, and I kind of, after seeing these slides, wish I would have paid a little bit more attention. I'm not going to lie about that.
Yep. So, but here, this is an example on the left-hand side. We've got our fuel, we've got our oxygen, and we've got our nitrogen. That's what makes up the air we breathe. It's about 21% oxygen, and the rest of it, is nitrogen and inert gas. Well, in this, complete or perfect combustion, this is kind of like that high school dance where you have an exactly even number of people, right? And everybody wants to dance.
Yeah.
So there's
and that
nobody.
happens often, right?
Yeah,
Like
right,
that's how
right.
it always works.
Nobody's standing along the wall. Everybody's out on the floor. Well, like you say, that really doesn't happen all that often. So if we go on to our next slide, we kind of see what happens, in the real world combustion is we've got our nitrogen, that's in the air. We've got our oxygen. We have our fuel. And what happens is not all of that fuel necessarily finds the air it needs to burn. So typically equipment has what they call excess air because we put more air through the equipment than what we need to burn all of our fuel to help ensure all of our fuel is consumed and it has the air it needs to burn. And if we were to look at that on a graph to see what that would look like, here we've got a chart that we can see we've got the one line that is theoretical perfect or stoichiometric combustion. And then we've got the other line there to the right that is, ideal combustion. We've got that right mix, okay, which is typically what happens. So you've kind of got that spot in between where you can see in between that gray and yellow line that we've got the right amount of air, we've got the right amount of fuel. The red line there is our carbon monoxide production, and we can see that's very low. As long as we have enough air to burn all of our fuel, we produce very little carbon monoxide. Now, if you follow that chart to the right, okay, that would be what we call our air-rich side, so we've got more air than fuel. You can see our oxygen level go up, which is the blue line. We still produce very little CO. The downside of having too much oxygen, though, is we're trying to feed all that air through the heat exchanger. And if we're going to put more air through the same size heat exchanger, what do we have to do? It's got to go faster, right? Yep. So when it goes faster, it has less time to give up that heat to the space. So more of our heating dollars go out the chimney. So when you're doing a combustion test, really what we're doing is we're measuring that to find out, hey, do we have that right balance of air and fuel? Okay, if we go now, let's move to the left side. So if we move to the left, we see that red line. As soon as we start to run out of air to burn all of our fuel, and now we get incomplete combustion, the amount of CO that's produced quickly increases. So it doesn't take too much, more fuel than air to start, having an issue and creating a lot of carbon monoxide. So, some of the things may cause that. That's one thing that a crack will cause. Because now if some of our air is shortcutting our burners and it's coming through the heat exchanger, maybe halfway up the heat exchanger, that means less air is coming across our burners, down here at the bottom. So poor draft. If you go out to an old piece of equipment, they've got those old dampers that were in the flue. Now they're motorized and they got a switch so it opens and beforehand. But if it was that old spring style, the bimetal, doesn't open up, you're going to run out of air because you don't have enough draft. So a lot of things can cause that. The other thing that can cause that is fuel pressure. If whenever that piece of equipment was installed, they didn't check the gas pressure and set it, if you're sending more fuel pressure to that equipment than it's designed for, you're going to overfire that piece of equipment. So, what an analyzer is really doing is allowing us to see inside that combustion process to find out what's happening and see that in the flue gas. So.
And something I just want to mention a little bit about this chart because we'll talk a little bit about it later. But basically, if you know 2 points on that chart, you're going to be able to calculate out the third point. So you're going to see why that's so important in just a little bit.
Yep.
But let's talk a little bit about where you can test. So right now we had a question earlier about like 80 and 90% furnaces. So what you're seeing now, you should be seeing on the slide right now, is a little bit about the different places that you can test and things that you want to look for when you're testing. And I think, Mark, you wanted to talk a little bit about that?
Absolutely. And you can see there's a long list, and not everything has to do with combustion. Some of those, because some analyzers have pressure diaphragms, so we can check external static pressure, which helps us find out how much airflow we have, in the system. We can check gas pressure, temperature rise, temperature fall, with thermocouples and the supply and return. But really what we're looking for is a non-diluted flue gas sample. Now, these two pictures here are of an 80 and a 90%, which, as we know, have draft-induced fans typically. So if we go into the flue pipe, if there's not a probe, a lot of boilers now are starting to come with a plug that you can actually take out to put your probe in and replace that.
Which is super handy.
That is really nice. If you don't have that, we're going to need to drill a hole in the flue. A lot of guys like to use high temperature silicone to seal that up. Especially if it's metal pipe, you don't want to put a screw in there because you might get dissimilar metals and corrosion that way, or noise, expansion, contraction. But high temperature silicone works great. If we go on to our next slide, we have some other examples for a water heater, boiler, what have you. You see on the left there, that's a boiler with an external draft hood on it. What we want to do is we want to check below that draft diverter so that we're getting that non-diluted sample. And a water heater, we're going down in below where that flue connects. So, and if you happen to encounter one of the real old piece of equipment, the furnaces that had the draft diverter in the front, what a lot of guys will do is they'll take a little piece of copper tube and it's a rubber hose to connect it so they can get up in each individual cell. Because any place we go in the flue, when our draft diverter is inside, we're going to have other air in there, which means our readings are useless because it's all that diversion air. Okay? Yep. Got another question?
Yeah, so Jason is saying, so do you find that excessive air over the heat exchanger causes a significant change in the combustion gas composition?
So a significant change from I assume he means a significant amount of air in the combustion chamber, not over the heat exchanger, was what I would say. So let's take, and we do some oil training, so I know kind of those numbers because I've done a lot of that training. So typically in an oil furnace, you want about 30% excess air is what you want in an oil furnace. And of course, we've got a lot of control over either an oil burner or a power gas burner. So if you're commercial, because you've got that air band that you can adjust, what we see if we open that up and get up to 35, 40% excess air, you'll see your flue temperature really start to increase, which means your efficiency is going to go down because more of our heat is going out the chimney. Okay? The other side of that is if we start to cut that back, and now instead of 30% excess air, maybe we've only got 10 or 20%, now our flue temperature goes down, our efficiency goes up, but our flame temperature increases. So we have the risk of damaging the heat exchanger from overheating it because now our flame temperature is higher. So one thing I try and stress, especially when we do our oil training, because you've got a lot more control over that oil burner than you do an 80 or 90% furnace, is don't chase the efficiency numbers. Don't start playing with stuff to, hey, I got another percent or two out of this. What we want is we want to look at the combustion process, our oxygen, our CO, and our flue temperature, and get that within the parameters that the manufacturer has specified for that equipment. Okay? One thing to keep in mind is when you look at the rating plate on that furnace, it says AFUE. Well, AFUE is annual fuel utilization efficiency. We don't get AFUE in one test. Okay? That's done in the lab. They're taking into account the jacket losses and all those things. So if you put in a 95% furnace and you do a flue test and you see that efficiency is only 92%, don't say, hey, I got a problem with this piece of equipment, because that's one test. That's not over the whole season, which is what that AFUE is telling you. So as long as your flue temperature, your CO, your oxygen, your CO2 are within the manufacturer's guidelines, you're going to get the AFUE that they publish, because you want to set that piece of equipment up to have the combustion process that they specify.
I have an interesting question from Bradley. He asked, how much does a chimney affect venting? how much does it make a difference?
Oh, that's a great question. Question is how does a chimney affect venting? Again, I'll go back to oil just because this is a great example. A few years ago, had a call. 3 mechanical contractors had been out to look at this boiler that was in an old, about 100-year-old house down in Lexington, Kentucky. And they'd put 2 different oil burners on it. It's in an old hand-dug basement, 2-story house with a big 12-12 pitch roof. And the chimney, so it was probably 40 foot tall by the time it went all up through that. And if you know about oil or power gas burners, you know those can be a positive pressure appliance. So when we check the pressure in the combustion chamber, it's actually a positive pressure because that motor on the burner is forcing the air through. Well, the contractor's argument was, hey, this is a positive pressure appliance. It doesn't matter what the chimney's doing. Well, when you look in the book, that's good for 16 feet of vent. They had 40 feet of vent on this piece of equipment. Guess what no one had ever done on that installation? They had never lined the chimney. So here's a 100-year-old brick chimney that all the masonry over the years had corroded, broken down. It was leaking like crazy. So what's happening, the draft that should be drawing our flue gas out of the appliance is getting lost in all these cracks, right? In all this old masonry that had broken down. I said, hey, you got to line the chimney. And they did that, solved every problem they had with that piece of equipment. So draft is a huge aspect in how equipment operates. And that's one reason why draft is very important. If you get into commercial, power burners or oil equipment, there's a barometric damper, okay, to balance that draft. So we have that set in 80 or 90%. 90%, another difference between those two, typically that flue is a positive pressure, okay? In an 80%, even though we have a draft inducer, the flue itself is still a negative pressure. So when we check our draft, we should have negative pressure in that flue, even though it has a fan on it. Because that fan's job is to draw the air through the heat exchanger, not blow it out the vent.
So this has a really good follow-up question then for Bradley. He asked, Jeremy asks, how do you know what the numbers should be? Percentage-wise, oxygen, CO, flue depth, pressure, all that stuff.
Yeah, typically that manufacturer is going to give you that information. And I will say this, boiler manufacturers are usually better about providing that information than gas furnace, forced air is. One thing that's in our manual is it gives you some general guidelines that are typically going to keep you out of trouble. And by the way, even if you don't have one of our analyzers, our manuals, you can download those, from the website. So you can go to ueitest.com.
But you should have one of our combustion
you absolutely
analyzers,
should, but
Mark.
absolutely you should. But I guess my point with that is get the information, so that you know what you're looking for. Now you can have that information, and without the analyzer, you can't find out what it is. So the expression is, if you're not testing, you're guessing. If you don't have it's just like a meter. Hey, do I have 120 volts? Yeah. That'll tell you get shocked. Doesn't tell you have 120 volts. So without an analyzer to measure it, you don't know what it is. But having that information is real important.
Yeah, and there are some general guidelines, and we'll kind of get into that in just a quick moment, which led right into where we were going to go with this, is kind of analyzing the results. So I'm going to tell you, I have read so many boiler manuals, you probably wouldn't even believe how many I've had to go through. And I'm specifically going to call out boilers because, as Mark said, they tend to lean a little bit better towards giving you the exact specs that you're looking for. So there's a rule of thumb that generally, if you're under 100 parts per million of carbon monoxide, that you're fine. But I'm going to tell you that, I've heard different equipment. I think we were just talking about it the other day when you had something that you were out, and the manual said it could be up to 200 parts per million. So that's why we say always check the installation manual. But the general rule of thumb is you definitely want to be under 100 parts per million. And it can vary depending on the size of the furnace and the boiler that's being used. And with the proper draft, like we were talking about when we were talking about the chimney and those type of things, if you have the proper draft that's pulling it out, that CO is going to quickly dissipate into the outside air. So the next thing is the carbon dioxide. And for any of you guys that might be out there working on boilers, this is huge because a lot of those manufacturers are actually looking at what the CO2 values are as opposed to what the CO and the oxygen levels. So If you have your gas pressure set right and the CO2 is right, they're going to say you're good to go. But always, always, always check the manual to see what it says. And I want to talk a little bit. We spent a lot of time talking about what is carbon monoxide. I want to talk a moment about what is carbon dioxide. So carbon dioxide, it's a byproduct of that combustion process. It's not usually harmful, but when you're in closed spaces, it's going to eliminate out that oxygen. So you're displacing all of that oxygen and replacing it with carbon dioxide. Every time we exhale, we're exhaling out some of that carbon dioxide. Everything that uses oxygen for life is going to create CO2. A fire is no different. And then I already talked about a lot of the boiler manufacturers are starting to use CO2 as part of that scale. So the other component that we were talking a little bit about was the temperature, right? So we want to make sure that the net temperature, so you're going to have a differential temperature going on there. It's the result of taking the actual stack temperature and creating the differential between the ambient air of the pre-combustion air. So you got to have kind of two numbers going on. And the most accurate efficiency readings are going to be when the net temperature is at its highest point. So probably don't want to be testing your furnace or your boiler when it's 80 degrees outside. Is that how I'm reading that?
Yeah, it's funny you'd say that because we actually get that call occasionally when they're trying to fire a boiler up, and it's a lot of new boilers have what they call warm weather shutdown. So if it's over 70, they don't fire to prevent somebody from cranking the thermostat up when it's hot outside. So yeah, typically you want to have that when you're in heating mode, heating condition. And if you've got a two-pipe system, on a 90% furnace, you want to take an extra thermocouple, and your analyzer, which we'll talk more about this a little bit, but you've got a plug-in for not only your flue temperature, but also for your combustion air. Because if it's 10 degrees outside and it's 60 in the basement, and we have a net stack temperature that's based on 60 degrees and not 10, we're going to have an inaccurate efficiency calculation because it's not getting a true net stack temperature.
And hopefully, I just want to talk just a moment about efficiency simplified. So it's the percentage of furnace fuel that's burned. So if you have an 80% furnace, it's going to mean that 20% of that fuel is wasted. An efficiency reading below 80%, that means that, or if you have an efficiency reading that's below 80%, you don't want to try to chase that efficiency, was what you were saying earlier, right? No. So if you have an 80% furnace and you're like, oh, if I just adjust it here, oh, look, I get 82, you don't want to do that. When you start chasing that efficiency beyond what the manufacturer scopes are, you're not only endangering the homeowner or the business owner, but you're getting that unit out of calibration and potentially also causing issues with warranty down the road if you so had to choose it. No. So another thing that we want to talk about, we talked about there's a lot of different tests that the combustion analyzers can provide for you. So this is just kind of a sample of different tests that our analyzers have for you that you can print out results. And we have a couple of new models that we're going to talk about in a minute that have joined our family. So as you can see, there's a combustion test. Depending on the unit, there's a commissioning test. You have that heat exchanger test that we talked about in the beginning. And then we have just a general auxiliary. So there's a couple of different ones. And then you can also have, if you have your unit, your combustion analyzer that has pressure and temperature, you can actually do a printout just for that. Yeah. So, oh, yeah. Yep.
You ready for some more questions?
Sure.
Absolutely. Yep. That's what we're here for.
So Bradley wants to go back just a little bit into a prior topic, and he asked, do you think you should line every chimney? Back to our prior topic of conversation.
Okay, yeah. Should we line every chimney? Go by that manufacturer's guidelines and see what it says. Especially, I tell you, we get into this a lot more, and I know a lot of you probably boilers aren't your main thing, but we really see that is, sometimes we'll say, oh, a clay line chimney or what have you. Boy, any type of equipment that's just an old masonry chimney, especially if it's, exposed on that outside wall, right? Not in the middle of the house is even going to be worse. But that tremendously affects draft. So, and now if we're replacing a piece of equipment that was maybe 60 or 70% efficient and at a really hot flue gas temperature, that's going to keep all that moisture that's in the flue gas in vapor state all the way out the chimney. Now we put in an 83 or 84 or 85% efficient piece of equipment, our flue temperature is lower. Once that flue gas gets to about 130 degrees, it's going to start to condense. So now that moisture that with that old inefficient piece of equipment that went out the chimney, now it doesn't make it all the way out. It makes it halfway up. And now that's going to start to eat away at our masonry that's joining all our brick. So yeah, anytime you're going to a newer piece of equipment, look at their guidelines, find out, and tonight there's 4 categories of vent, category 1, 2, 3, and 4. Most of your 80 percenters, if they're going vertical, are typically category 1, which is going to tell you to line, have a flexible chimney liner or B vent, is what that's lined with. So the fuel gas code spells all that out, but it's really important as that efficiency goes up because the flue temperature gets closer to that condensing point.
Louise, this is a question for you. Rob is asking, so how often should my analyzers be sent in for calibration?
Every single year.
Every single year?
Every single year. Anything that tests carbon monoxide that you're going to be using to verify, you want to make sure that you have it recertified every single year. And you'll actually see how we work that in for your analyzer to make it a little bit easier for you, okay?
Hey, let's go back one slide too real quick if we could.
Sure.
Talking about these tests and the printout to be able to do that, really what that does is that allows you to take what you're telling that homeowner from an opinion to a fact, because now you can document it. And if, a lot of people get multiple quotes anymore, they call multiple contractors to come out. So, if so-and-so's heating comes out and says, yeah, I think you got a problem because, see that flame, it really ought to be more blue than that, kind of lazy or whatever. Or you can run a combustion analysis and say, hey, here's why I think you've got a problem because here's exactly what's happening. Who are they going to have more confidence in? Who are they going to question? So, to differentiate yourself from that other fellow is big.
Carl has an interesting question. He asks, is there a difference between residential versus commercial combustion analyzers, and is there a difference in numbers?
That's a great question. The difference between commercial and residential. There is to an extent, and without getting too in depth, you can have an additional amount of hydrogen in the flue gas with your large high BTU burners. So the high-end analyzers have what they call an H2 compensated CO sensor. So it's going to give you an accurate reading. And that,
but that's going to be on a lot of your higher end commercial.
That's big.
Almost virtually on
your
the
power
industrial.
burners. Multi-million BTU equipment. If you're the contractor that primarily does residential, and you've got a couple of churches that maybe have a 2 or 3, 400,000 BTU piece of equipment, that's not the guy I think that's in the threshold that needs that commercial analyzer. Now, you've got big multi-million BTU power burners, that light into multi-horsepower, boilers or incinerators that you're trying to check. Yeah, that's when we start getting into those industrial analyzers.
Yeah, so. And those industrial analyzers are a little bit different, as Mark said, but all of the analyzers that you're going to see here tonight and that we're going to talk about are all going to be designed for residential/commercial. So you're going to be fine with any of those. But if you are into more of the industrial side of things, certainly I'm sure Jackson will share my contact information with you, and we can certainly talk about what your options are in the combustion line.
Yeah, because then we've got choices of sensors and SO2 and
right.
There's a lot of things
getting into. But for most of your residential commercial purposes, it's going to be the same type of unit that you're going to be able to use.
Thanks. These guys have a lot of questions about chimneys. So the next one from Ronald is really quick. Does the diameter of the chimney affect the downdraft in the chimney?
Oh yeah, when you look at a chart. I apologize. Yeah, does the diameter of a chimney affect the downdraft or the draft of that chimney? I mean, 3 things really affect draft. One is the height of the chimney, the diameter, and your temperature difference, okay, between the indoors and outdoors. So, the fuel gas code is going to tell you that, hey, if you've got so many feet of horizontal run and so many feet of vertical run, what size chimney you need for a certain amount of BTU. And of course, we've got to add up everything that's going into that. So if we have a 100,000 BTU furnace and a 40,000 BTU water heater, we've got to combine that total BTU. And depending on how tall that chimney is, depends on what diameter we need. And if it's too large, it's not, you're not going to get enough draft because it's just, going to stall. So it just kind of depends on what, and I don't have all those charts memorized, but you know the vent manufacturers all have that chart. So when you look at that chart to say, hey, here's my horizontal and vertical run, here's my BTU, what size do I need? So.
Thank you.
All right, so now we're going to jump into a little bit of the actual combustion testing itself. So unfortunately, we weren't able to bring in our own furnace or boiler into this room right at the moment. But so we have some pictures, and Mark's going to show a little bit on the analyzer. In case you guys are wondering, Mark is using one of the newest combustion analyzers to our family line, which is the C163. Which I'll show you all the specs on it. But what Mark said in the beginning is we want to make sure that we're turning that analyzer on outside in the fresh air. This particular analyzer in the ambient air has about a 60-second warm-up time, so it's a great time. You want to make sure you're gathering all your tools to go into the house, turn that on, you know, leave it in the front of your truck. Don't hang out by your exhaust pipe, okay? But you want to make sure that, you know, you turn this on, give it a chance to warm up. And 60 seconds is pretty quick. It's amazing how many of your tools you're able to grab in there. And then the next thing, depending on your unit, this particular unit does have pressure in there. So we were talking about how important, you know, static pressure is, draft, all of those type of things, and just checking the gas pressure. So as you can see, Mark was able to plug in the hoses for his built-in manometer, which makes it really convenient. Now you don't have to, you know, pull out a manometer and a combustion analyzer. Your unit has everything inside for you. And then the next thing is we want to talk about the flue probe itself. So there's two components on that flue probe that are actually going to plug into the analyzer. So this first part that Mark's plugging in is the inlet tube, and that actually runs up. It's where the actual combustion air is going to get drawn up into the combustion analyzer right there. So he was able to put that in. It plugs real easily into the water trap for us. And then the second thing, we were talking about temperature. So you're going to want to insert, it's a K-type thermocouple. So we want to make sure that we watch for the polarity, right? The bigger side goes in the bigger hole, the smaller side goes in the smaller hole. You can try to force it, it never turns out pretty. So you want to make sure that you're watching for the polarity to be able to do that.
You'll have to send in more than once a year if you force it in, right?
That is very, very, very true. And you get some crazy numbers when you reverse that polarity. When you think it's supposed to be getting hotter, all of a sudden your analyzer is saying it's getting colder. So the next part of that is you're going to want to insert the probe into the stack or the flue, or if we were talking in the case of those boilers that have the built-in ports, that's where you're going to be able to do it. And Mark has the flue probe, and there's a couple of nice features about this particular flue probe. So you might be wondering what this little triangular shaped cone is going on there, but that's actually a depth stop cone. So once you've actually drilled that hole, you're going to want to put your analyzer. You're going to want to make sure that flue probe is setting nice and center in the middle of that venting. And then you're going to want to put this up to make sure that you've created a nice tight seal in there, because you don't want any of that combustion air to be leaking back out, because that kind of defeats a little bit of that purpose going on. So once you've done that and you have it nice in there, you're ready for your combustion testing. So this particular unit, and actually everything in the family line, has a couple of different screens. So the first combustion test results on your first screen, you're going to be able to see your CO2. You're going to be able to see your CO, your efficiency, your flue temp differential, because it's going to show you T1 and T2. And that's one of the nice things that we did about this line, is actually all of the analyzers in this line have a nice 6-line display. So you're seeing those 6 primary features that you want to be able to see, those readings, on one simple screen. You don't have to start scrolling through the menus. And then there's another screen that'll show you a bunch of other, it's going to show you that excess air you were talking about. It's going to show you a few of the other results as well. But what else is really nice about this one, because it has the built-in manometer, you're going to be able to adjust the pressure right there at the gas valve.
Right.
And you're going to be able to see what that did to your combustion results without having to start fumbling through a whole bunch of tools. And there's a few things that we do with our analyzers to make it really, really nice. So they have magnetic boots on the back, which makes it hands-free testing, as you can see in this little picture right here. And on the back side right there, you're able to mount it right to the unit and not have to worry about it, which, we all wish we had more hands when we're trying to do our jobs, right? So this takes away having to hold it. And depending on the model that you have, you can have an infrared printer that aligns with the unit, or what Mark's picture here shows us is that we actually have some models that have an app-based printer. And that's huge. It makes it easy, it makes it simple. And we were talking about why combustion analyzation is so important, not only for safety, but I told you there was another component, and that has to do with warranty. So a lot of manufacturers are actually starting to see a high amount of warranty costs from improper installation, poor or little use of test instruments for the install, no documentation. Because if you call a manufacturer and you say, hey, this isn't working right, one of the first things they always ask you is, what's your gas pressure? What's your CO2? And they're starting to tie this to the warranty type of things. So you want to make sure that you have all your ducks in a line before you do that. Because that is a hugely important thing. You want to make sure you have the right tools for the right job. I told you I've spent a lot of time as of recent reading boiler install manuals, and there are a multitude of brands out there. When you start getting into those manuals that explicitly say you have to have a combustion analyzer to do this job properly. And if you call them and they ask you all those things and you say no, they're not a whole lot likely to help you, right? They're going to say, find somebody who does, and then call us back.
Yep. Yeah. If
That's
they
the
say,
nice way. That's the nice way.
They say, what's the gas pressure? And you say it's right. That's not quite the right answer. Yeah.
Right. The flame looks right, not an acceptable answer to manufacturers. And that goes for the furnace manufacturers as well. So, we want to make sure that you know. And if you ever have doubts of what kind of unit you might need based on what you're seeing in a manual, you can always reach out to somebody at UEI, and we're always happy to help you get into the right model. But what you're going to see is there's a multitude of things with this particular unit that you're going to be able to do, and it's going to cover all of those things that you see in the manual. And that kind of leads me into what makes UEI different, right? You need the right tools and those type of things. So I want to talk a little bit about what the UEI difference is. And you may see it on our packaging, you may see it on our website, and you may go, I have no idea what that means. It looks really nice and fancy, but I don't really know what it means. So if you remember a little while ago, Mark and I showed you that nice chart that showed you if something was air rich or fuel rich and those type of things. And I mentioned if you knew 2 points on the mark, you would be able to calculate out the third one. Well, there's been a challenge out there because the traditional combustion analyzer takes your oxygen and your carbon monoxide measurement and it calculates out your CO2, which is fine, but as we showed in that perfect versus incomplete combustion, we're always breathing oxygen. And an oxygen sensor doesn't know when to shut off. And so it's constantly reading. So that oxygen sensor could be fine on a Monday, but by Tuesday it's had its day and you just don't know. And if you've ever had to purchase an oxygen sensor, you know those can get very costly very, very quickly. So even when your analyzer's off, it's constantly reading oxygen. And that's a problem, right? Because how do you stop it from reading oxygen?
Yep.
Not a manufacturer has figured out how to make that happen, including us. But we decided that there had to be a solution. And that solution, once again, going back to if you know 2 parts, you can calculate out that third. So what UEI technology is that we have a CO sensor and we have an infrared sensor that goes through the CO2. And then we calculate out your oxygen. So now you don't have an oxygen sensor that you have to worry about replacing. So now your cost of ownership has dramatically decreased, and that's huge. It's also a nice peace of mind knowing that you don't have to worry about that oxygen sensor.
And the biggest cost is not just the oxygen sensor, but it's going out, driving to the job, getting your tool out, and finding out it's dead. And now you got to make a trip back.
So is there any consumables that are in that product or in the analyzer, or is there the sensors consumed?
That's a great question regarding
So-
consumables. Yeah.
Over time, sensors will eventually wear down, but oxygen sensors are the most prevalent in that.
Well, and the difference is, there's a chemical that reacts to create that voltage, right, to read. Well, the reason the oxygen sensor fails, even sitting on the shelf, is because it's always having that chemical reaction because it's always exposed to oxygen. The difference with the CO cell is it's not always exposed to CO. But as far as some of your care for the analyzer, when you're done with the job, in fact, these new ones, they won't shut off if the CO level is above a certain point. That pump continues to run to purge the CO out of the instrument to help lengthen the life of that cell. And that's where, I know we kind of joke around about, hey, don't be standing by your, exhaust of your truck and so forth. But, if you take this and say, hey, what is it? You're going to kill that sensor pretty quick because 12,000 parts per million is going to slam that cell. And to the question earlier about, industrial analyzers, some of those industrial analyzers have a cell that's good for 10,000 parts per million CO. Okay? You don't have that in a residential, but again, that's really big equipment that you need that for. So that's a consumable, is that chemical in that cell.
CO2 sensor, just for the record, is that gas never actually touches the CO2 sensor, right? So hopefully you guys are seeing that slide with the little diagram that goes on there. So the gas actually goes through a little IR bench, and it never actually touches the sensor when it takes that measurement for you. And then it flows over the CO sensor. So that's different than everything else out there.
One other consumable too is there is a filter inside that trap. Now, if you're doing gas, propane and natural, it's going to go a long time. If you do much oil, then you're going to want to take your smoke pump. If, for those of you who do oil, you should have a smoke pump where you put that in, you put the paper in and take 10 draws. Do that first. Try to get below a number 2 smoke, and that'll help that filter last longer. But it's just a little paper filter you can take out. You can change that in the field easy.
And if you are a guy that's working on oil, by the way, we do also sell those oil kits. So you can have that smoke pump in the paper for you as well. That's an option that we have.
Quick question from F. Moore. Can you test static pressure with your analyzer without having to go through the warm-up sequence, saving analyzer sensor life?
So you're not really going to do, the answer is, yes, you can turn it on with just the pressure temperature going on, but even when you turn it on, you're not damaging the sensor. So by going through any of that, you're not going to wind up doing any damage because you're in the ambient air.
Unless you put that in the flue and you're getting CO. Yeah. If you don't hook up that probe, you're not drawing any CO through it. You're not consuming that cell.
Yeah. And you have the option to turn off the pump as well. So. So I mentioned that UEI has launched our new family combustion analyzer line. So you guys may be familiar with our line, and remember that you had to choose if you wanted 2 lines or 4 lines and those type of things. But we actually wanted to come out with a line, and it's a cohesive line. So when you pick up a UEI combustion analyzer, you're going to know that it's a UEI combustion analyzer. And there's 6 features that we built in. So whether you have the entry level or you have the top of the line, this is in every single one of them. So the very first thing, and we actually recently surveyed a bunch of our contractors out there, that was the contractor favorite, was the 6-line display. So it's a professional grade analyzer. It's going to show you all of the information that you need on the screen. Another thing that we did, we modified it a little bit. If you're familiar with our analyzers, you might notice that we've always had a multimeter style dial going on right here, which makes it easy. You turn it to the test and you're ready to go. You don't have to start going through any of the screens, no getting lost in menus, anything like that.
I have more questions, but keep on going.
Okay, we'll answer those as soon as I finish this one. I talked about the fact that we don't have an oxygen sensor, so that's once again going to reduce the number of sensors that you have to replace. We were talking about byproducts that happen in the combustion process, and NOx is a byproduct of that combustion process. And if you don't have a NOx filtered CO sensor, you're going to get errant CO readings. So we have NOx filtered CO sensors on all of them. The 5th feature may not be as important for those of us who are in Indiana. Sad face, because I really like the mountains. But we have high altitude compensation. So whether you're working at sea level or you're working at 20,000 feet or above, your analyzer is going to work flawlessly for you without having to have it sent in for additional recertification and calibration because you're working in the high altitudes. And the very last feature that we built into all of these analyzers is an LED water trap indicator. So when you turn on these units, you'll actually see a blue flashing light when the pump is on. And it makes that water trap a lot more visible for you. So water being a byproduct of the combustion process, you want to make sure that you're emptying that water trap. And it's easy to forget about, right? If it's not lit, if there's not something calling out to it, you're not going to get a lot of water. But what happens is, as that builds up, you wind up having the risk of it running back into the unit, and you can wind up damaging your sensors. So this light makes it very easy and very visible for you to be able to see. So you had some questions that we wanted to go before we get to the next slide?
I do. I have a question from Brad Woods, who
Oh, yeah.
wants to say hi.
Yep.
He says, do you have, or can you go over a printout for good versus bad readings? So do you have a copy, the one we can look at or go over or anything like that?
Well, as far as those good versus bad, that kind of goes back to what we were saying earlier about, that particular manufacturer's, manual on what they want to see. But in our instruction manual, there are some general guidelines, that give you, hey, if you're working on an 80% furnace, these are generally acceptable results. If you're working on 90%, these are generally acceptable results. So, but again, defer to the manufacturer if you have it. Now, if you don't, go by those general guidelines, and those will generally keep you out of trouble. It may not be optimal for that piece of equipment, but those guidelines will keep you out of trouble. So,
Okay.
yep.
And Jeremy asks, does it also measure temp rise?
Yeah, that's where you've got your two temperature. Does it measure temp rise was the question. That's where we've got the two temperatures. Now in this case, I've got the probe plugged in, and we've got another thermocouple, and we packed our case back up. But all we have to do is take our probe out and put another K-type thermocouple probe in, and then you can put one in the supply duct, one in the return duct, and that's one thing with static pressure tips. We can put a static pressure tip and a temperature probe in the supply, a static temperature and pressure and temperature in the return, and now you've got the external static pressure, temperature rise or temperature fall, or whether we're heating or air conditioning. So, yeah. And if you set that up on the auxiliary screen,
Yep.
you can print that out. So now you'll have a printout of the external static pressure, supply, return, and temperature rise or fall. So, yeah. And one thing while we were talking about the water and
Yep.
the moisture trap, another thing with care for an analyzer this time of year, take it inside, right? Don't
Yep.
let it freeze. What happens to water when it freezes? It expands.
Yep.
So we get very much moisture on those cells. That freezes on the cell, it expands, you have the potential to crack a CO cell.
Yep.
and have to have that prematurely replaced.
And honestly, on that point, I'll tell you, tools have a lot of technology in them, right? A lot of those electronics. So I really urge you, and Mark is right, especially during this time of year when we start seeing those colder temperatures. But I have a general rule of thumb. If you wouldn't leave your cell phone in that vehicle, don't leave your high-end tools in the vehicle, because you're risking damage of all of the electronics inside. So not only are you risking, if you didn't empty the water trap, you risk it freezing, but you're risking damaging the electronics. And I know you guys work hard for your money, so anything we can do to help you, keep that protected. Take it inside, take it out of your vehicle. I know it's a pain sometimes, but it just takes a few minutes, and it's gonna help the lifeline of your particular units. So, what you guys should be seeing right now is that new C160 series combustion analyzer family. As I mentioned, it is a cohesive line going from left to right going on there. And there's a particular model that I really want to talk about. So, you can go to our website, you can download all these specs, you can go back and refer to this slide. But I got to talk to you a little bit about our C163 model, which is this one that we've had out here on the table all night. There's a couple of features that start on the C163 model that I think are really important for you to have. So we talked about the fact that you can do pressure with it, right? So the C163 is the first model that adds pressure. The C163 also has what we call a wireless module or an app-based printer. So no longer do you have to fumble with rolls of paper and having an external printer. You're actually able to print it right to your phone, which allows you to email it out. You can have that attachment, you can attach it to your jobs, you can send it to the homeowner, whatever you need to do with that, right? As we look forward, as society progresses, right, we're becoming more and more of a paperless society. And if you're like me, I don't really like having a lot of paper around, but if it's on my phone, it's great. You guys that are coming up into the field, if it's not on your phone, right, that's how we all learn. We all have our phones, we're on them all the time. It just makes it a little bit easier. But there's a third feature that starts on this model that I think is just huge for you. So we were talking about the differences between residential, commercial, industrial, and those type of things. But starting on that C163 model, you actually have a CO overrange pump. And I want to talk to you a little bit about what that does. So that CO overrange, so if you've ever started a boiler or you're working on some big equipment, when that startup happens, if you put your flue probe in right away, it's going to get overwhelmed with carbon monoxide. And that's how you wind up burning out your CO sensor. Or the stories that I've heard, I wasn't sure it was working, so I stuck it in the tailpipe of my truck. And we've heard it. You've had a buddy that did it. Hopefully you learned from that buddy. But we wanted to help protect you. So we put in a CO overrange pump. And what that does is when it sees high levels of CO, that main pump shuts off, so it stops drawing in that flue gas. And a secondary pump comes on, purges it out to the side. So now I've given you an analyzer that not only doesn't have an oxygen sensor to go dead, but now we've protected your CO sensor. So your cost of ownership to be able to get this recertified every single year has just gone down dramatically. And the other thing, right, because I can talk about all of these great things, and I tell you that it's a lower cost of ownership. I tell you that it's priced right. So I can't tell you what your wholesaler, call Jackson Systems. They'll be happy to give you your price on your units. But what I want to show you is that C163 model, its base price is less than $1,000. And it's going to be able to do all of those things for you. And you can see that we even have a flat rate service. And what's really nice about flat rate service pricing is when you send it in to our Indianapolis facility for recertification, you know what it's going to cost you every single year. And I want you to think about that. If you have other combustion analyzers that aren't UEI, you always go, ooh, how much should I put in the budget for this year? You know, I've heard estimates, $200 just to replace an oxygen sensor, $200 for this. On average, maybe $300 to $500 a year to be able to maintain that unit. That's going to do all the same things. We do flat rate pricing. We've eliminated your oxygen sensor. On that C163, I've now been able to prevent you from overwhelming your CO sensor. That's huge, guys. Your cost of ownership. Think about when you buy a car, right? Like if you're going to buy a used car and you start looking at the brands and you go, oh, that's a really good deal, but if something goes wrong, what's it going to cost me? And we like that flat rate pricing. We like no surprises for you. And that's hugely important. And I know that I wanted to talk a little bit about how our recertification program and our warranty tie together. And I think that's an important thing to know because we wanted to help you guys remember. So all these analyzers have what we call a dynamic 6-year warranty. How that works, though, is every unit that's purchased comes with a 1-year limited warranty. Every year you get it annually recertified, you can extend it out to 6 years. So, you know, we talked about there are some consumables in there, right? Like batteries. You got to make sure that you're changing the batteries. These do all come with rechargeable batteries and the powered cord to charge them. You know, your flue probe, your filters, those type of things aren't going to be covered under the warranty. And if you get really ticked off at a job site and you decide to throw it outside and run it over your truck, I'm not covering that either, okay? And I want to tell you, I've heard some of those stories and I've seen some of those analyzers, okay?
Yeah, when they come in with tire tracks, that's a pretty good indicator.
It's a really good indicator, and I know we all get frustrated, but that recertification program, and there's a very real reason that I call it recertification rather than just calibration. So if you're not familiar, my facility is here in Indianapolis. We're just on the opposite side of town from Jackson Systems. So I'm up there in Indianapolis, and that's 100% of our recertification lab. And that recertification process is a lot more than just like, checking the sensors and good to go. If it moves, it's covered, right? Like it's going to get checked. It's a 30+ point checkpoint that they go through. So on this particular C163, they're going to not only check that your pressure is working right, they're going to make sure your temperature is working right, that your pump and all of those type of things are working properly. And at the end of it, they're also going to test it against the gases, any updates that may need to be done. They're going to do that for you as well. And the other thing is at the end of it, you actually get a certificate of calibration that shows what it was tested against, your particular unit, and what your results were. And that's huge. Especially we were talking about, you want a CYA. So if something goes wrong, you're going to want to be able to say, hey, you know what? I did have this professionally recertified. And that's another peace of mind. And something else that's really exciting, because you're like, oh, that's great, you have flat rate pricing. But the other thing that's also really exciting is the fact that we, on average, 2-day turnaround. And I want you to think about that. So you send in a combustion analyzer, my lab guys get it on a Monday. Most of the time, those are coming back out to you on a Wednesday. So we just actually had a situation when I was talking to one of Mark's counterparts the other day, where a contractor didn't think his analyzer had actually been sent out for service. But what he didn't realize is not only had it been sent out, it had been returned back to his office. That is how quick it was. And so I shared that story with my counterparts in one of our meetings the other day. And I think each one of us had a story that was very similar to that. So I just want to tell you, having an average of a 2-day turnaround time, that is huge for you, because you guys spend a lot of money to buy an analyzer. You want to make sure it's upkept right. And I will tell you, if you get really bored and you think about it in July, my lab guys will really, really like you. Because unfortunately what happens is we don't think about these things until the heart of the season, which I'm very proud to announce that they are still maintaining on average a 2-day turnaround time. But I'll tell you, they'll really like you in July if you keep them busy. So make sure we're sending that in. You're going to get that certificate of calibration, and you're going to be able to just extend out your warranty. And I think that's a really nice thing. And there's one other thing that I did want to talk to you. I know. I just looked up at the time. We've been having so much fun here, and we probably have some maybe more questions that are waiting here. One of the other things that I did want to just take a moment to talk about here is. We talked a lot about you're walking into different places. You never know what you're going into. We have a portable carbon monoxide detector. Has a nice little clip on the backside. And what's cool about our COA2 wireless CO detector is not only is it a standalone unit, but it can also run to an app. So you can log, store, and record. And that is another huge thing, because what all of this has been building up to that we've been talking about tonight is why it's what the benefits of having this is for you, right? So you walk in, you have a carbon monoxide detector. You're able to detect everything when you go through that house. You're able to perform those combustion analyzer tests. You're now adding a value-added service for your customer. And Mark was talking about all those other contractors that are out there, and people do price shop. But you know what? People are willing to pay a little bit more for that guy who knows what he's doing, who has the right tools, and is going to give them that peace of mind. Another thing is knowing that the job is done right. So we talked a lot about what those manufacturer manuals say and those type of things. And that's really important, because when you walk away and you leave and something wasn't done right, how much are you going to make on that callback? Because I think the last study I read is actually contractors lose about $300 and some every time they have to do a callback. So now, if you have the right tools, you're going to know that the job is done right. You're also giving the homeowner a peace of mind, and that's huge, right? When you go in and you see Mrs. Smith and you go through all of these type of things, and you can say, hey, you know what? You have this furnace, and this is what it's supposed to be, and now you have the documentation. And the other thing, I'm going to guess, I cover a lot of states for UEI, and I ask a question in every one of my classes is, how many of you guys got into the HVAC world because you love sales? And somebody on this broadcast will probably type into Tyler and tell him, yes, that's exactly why you got into HVAC. Most of you guys, sales was probably the last thought on your mind. And you have to be the salesperson. You're not only the technician, but you're the salesperson. And so now you actually have something that's going to give you the documentation to show Mrs. Smith, like, hey, you know what? This furnace, this boiler, it had a really nice life, but we got some major problems going on, and this is why you need to upgrade. And they're going to look at that, and they're going to see a printout, and they're probably going to take a lot more credibility in that than, you saying, hey, you know what? You need a new furnace. Like, it adds a bonus to it. It's a professionalism. It's going to help keep that warranty. And it's going to give you documentation for future reference, right? So you go to Mrs. Smith's house every single year, you're able to see that printout every single year because you're able to attach it to the job. So, having the right tools, I can't urge you enough. Call these guys, get the price quotes on your analyzers. They're priced right for the marketplace. And I want to make sure you guys are doing the best job that you possibly can. So, do we have some questions over there?
Jeremy Davis said, I want to be one of those cool kids. Brad did ask, so what type of case does it come in? This was a question from
Yeah,
what
so
kind of case?
starting at the C162 model and on up, it's going to come in this nice red, hard plastic blow molded case that comes. I don't know if we're going to be able to.
Yeah, we'll try.
We'll try. We're just going to throw things around.
Yeah,
That's the time of night we're at, guys. But if you notice, it has all of the nice foam in there to protect your instrument for you. If you buy a unit like the C163 and you're like, you know what, I really love that app-based module, but I just want to have a printer too, it already has the cutout ready for you to go, or you can use it for some extra storage. But all of your tools fit very nicely in there, and it's very easily protected for you.
And even the other K-type thermocouple probe that I mentioned earlier. So.
That's right.
Is it insulated?
It's not insulated. It's just the foam is to keep everything in place. But yeah, and that's the reason for taking it inside at night.
Exactly.
Or anytime it's for not just at night, frozen during the day, and it's out in a cold truck. But yeah.
Yeah. Or extreme temperatures, anything extreme. And that's why I go with the general rule of thumb, whether it's hot or cold outside, if you wouldn't leave your cell phone in your vehicle, don't leave your tools.
Here's an interesting question. Is there a way to have two combustion temperature / pressure sensors to check the temp rise and pressure drop on the furnace at the same time?
Yeah, you can check the question is there a way to do your pressure drop and temperature rise at the same time? And yes, there is, because you've got two temperature inputs for your K-type probes, and you've got both sides of the pressure diaphragm. So one of those is the positive and one's the negative. So when we put, one of those, let's disconnect our probe here just so I don't have too much hanging around, and check and make sure I get this in right. So right now, we've got, I'd look
Remember,
at it.
Mark, you got to check the polarity.
If I look at it straight on instead of at an angle, right?
Okay, all right.
So,
just,
So
see,
here
it happens to the best, okay?
Yep. So here we've got our two thermocouples plugged in at the same time. And now I don't have static pressure probes on here. This, just has the tube, so you'd want to get, which we have the static pressure tips. But that allows you, in that auxiliary screen, that allows you to choose what parameters you have displayed on that screen at one time. So that's where you can select T1, T2, your delta T, which would give you your either temperature rise and fall, and then your pressure differential. So that's going to give you, what your external static pressure is.
And you also have the pressure temperature test as well on there. So. All right.
Hey, any others?
Nope.
All
We are
right.
good. Well, I really want to thank everybody for joining us today. Hopefully you found this informative. If you guys have any other questions or anything like that, feel free, contact your Jackson specialist, reach out to myself or Mark Jones. We'll be happy to make sure that we're getting you to the right thing. Mark, I really appreciate you coming and joining us today. A world of expertise that you're able to bring to us. And I also want to thank Jackson and everybody here for inviting us in. That's all I got tonight.
We did have one final
Oh,
Okay.
all right.
question. Charles just got in there.
All right. We'll allow it. We'll allow it today.
So Charles asked, can you test gas pressure too?
Yes.
Yes.
Yes. Can we test gas pressure? Yes, we can. And it's up to, is it 60 inches or 40?
I believe it's 40 on those.
Yeah,
but I'll
40
have
inch.
to double check.
I think you're right.
think
I think
it's
it's 40. I think it's the EM201B that goes up to 60 inches.
Yeah.
So,
But for most of your residential commercials,
Yep,
you'll never
exactly.
go anywhere near
Right.
40 or 60 inches of water column. So.
and propane and natural. It'll
Yep.
do both.
Yeah,
So,
you have
yeah.
pre-programmed gases in there, guys. One of the things that we didn't talk about is you want to make sure that you're putting it on the right gas because, as we know, you'll get some different results going on there. So they all have pre-programmed fuels in there for you as well.
Mm-hmm.
Do we have anything else? All right.
All right. Well, thank you.
Thank you, guys. We appreciate you being here, and we look forward to the next time that we get to present from the Jackson Studios.